Okay. So yeah, simply let's go on and look into the program, start the project, create the schematic. Let me check what we have planned to do. Okay, schematic. Let's do it. Coffee break. Hey, wow, we have a lot to do today. Okay, so yeah, let's start. So as I said, you have the projects here, the projects folder. These are the examples. You have this as well in the default installation. You have seen maybe if you open one of the files here, do a double click. Yeah, I know. So you see this is a read-only file. If you would like to change this, you have to do a save as in your personal folder. But that's not what I want to do. I really want to create a new one. So before I do this, I have to go back one step because I have seen before if I open the Managed Libraries folder, you see the list of files. And if you look into your, if you have it running, you see that here you see green dots, right? Yes. This means the libraries are available for creating a schematic. So I fiddled around, I switched them on off, so I wouldn't have them. To switch them on, or you can also select and say, I know I only use 3 or 4 libraries, then I can switch off all the other libraries and select these 3 or 4, 5, and then if I add components into the schematic, I only will see these selected ones. So that makes it's a better overview. So it's not so distracting to have a big number of libraries. And I want to do the default settings. So to switch them on, I simply do a right click onto Manage Libraries here, say Use All, and you see now they're loaded into the memory and they're available for using them. Okay, close this again. So I'm in the projects folder. There is a project folder, that's my documents. I will take this one. You see if I open it, oh, I have already some projects in, okay. I do a right click onto projects and see and select new project. What's the difference to new folder? An ED project is also a folder, a subfolder of the projects folder, but it automatically creates an ED project file where we save all the settings you do while you're working with it. If you don't use projects, then this also can be done. And you would close Eagle again, then when you start it, you start with the control panel and nothing else. If I use a project, I have a schematic open, I have the board open, I have the text editor open, whatever, I have a library editor open, and I close Eagle, Eagle will store all this information. If I start it again, it will start exactly as I left it. So I have all the windows open as it was before, all the settings as it was before. It's a very simple projects mechanism, could be improved, but it's very flexible. Yeah, I recommend to use a project because it makes things easier. If you do some settings, I don't have to do it again next time. I simply get the same situation as I left it. Yeah, okay. So I say new project. Yeah, useful name. Yeah. My useful names.
Test 3.
Yeah, test 3. Yeah, okay. Yes, 1, 2, 3. That's the project. Okay, and enter. And now I have created this folder 1, 2, 3 in the projects folder. You see, there is a green dot. This tells me this project is active. I could have a description for it. I could click here and say edit description, type something, whatever you want to, so this appears also in the right hand side here. And then next step is, yeah, typically you start with a schematic. I do a right click here, say new, and choose schematic. By the way, all your operating systems are speaking English, so Eagle is in English. We support one more language, that's the German language, so if you would have a German setting or operating system, it will automatically talk in German to you. At least, yeah, all the stuff is translated. We have some English words because nobody translated yet. But okay, it's decided by the operating system. Okay, schematic. Oh, this was. Yeah. Okay. Yeah, I'm sitting here like an idiot, so I'll go a bit more. It's better. Okay, new schematic. Schematic editor window. That's it. White. It's like a white piece of paper, sheet of paper. You see. Yes, that's the user interface. Get used to it. It might happen that we will change in about 2 years again. I don't know. Depends on what happened. We talked about fusion, integration. I don't know. I think the plan is maybe to get all the beneath the fusion hood. We want to get all the modules. Electronics would be one of these modules. But at the moment, we and also the dev team, we can't imagine that, for example, the fusion interface would work for Eagle. The way how we work with our program does not fit to the way how you work in Fusion. How should I bring all these commands and all these options into a reasonable user interface so that it's usable? So that's things we are thinking about. There are not really plans made, but there are some tendencies to go into the modular design as we discussed earlier today. But yes, what we have is on the left-hand side, that's the command toolbar. All these icons represent the command you can start. On top you see, okay, there's the simulation toolbar, which is switched on by default. You could switch off it off also. You could also, you see, we call this it's the action toolbar. Here we have file open, save, print, all the stuff, switch the board, zoom in, zoom out, and for example, designing. But yeah, and if you activate one of the commands, let's take for example the net command, you see you have here parameters that belong to this command. So yeah, that's basically what you can do. And there are a number of ways to work with Eagle. The classic way is to click on one of these icons here, say net, then click into the drawing area and execute this command, draw something. If I would have objects already in the drawing area, I could also use a right mouse click onto object. I get a context menu with all the reasonable commands you can execute on this. So either you can do command selection, click onto the object, or right click onto the object and select the command. You have both options. That's we have founded in the long story we have. In the beginning we all had commands. You activate the command and then you do it as the classical way, or you do the right click. You could also execute all the commands in Eagle by typing it into the command line. So if you say, I want to draw a line, type in line, for example, L-E, or it's automatically substituted line, enter, and then I can draw a line. So also this is possible. The reason is, I mentioned the script files in the beginning. So you could write a text file with all the Eagle commands and create a whole schematic. Or you could create a whole board of this. And we want to keep this script functionality because that's something, okay, a beginner would not use. Probably they will click onto the icons and start doing something. But it can be much more efficient to type a name or a command in the command line, or do something working with coordinates. I know that's also, if I tell this you now, you say, hey, what's typing coordinates, you're crazy. But there are really benefits to do it this way. Sometimes it helps, it saves time. So we have basically 3 options. Click onto the icon and then the object, click the object, and then execute or select the command or type something in the command line and execute this again. So most are working in a kind of mix. And that's also something how would I bring this into a Fusion interface. So that's the things we are thinking about. But okay, yeah, basically that's the way. Okay, I've done something. I can undo every step I have done. Undo, redo. So I have it back for. The first step, if I create a schematic, would be, you don't have to, but it makes sense to place a drawing frame so they get the feeling what's the size of the drawing area here. It's basically 4 by 4 meters, so you can make schematics. Some people do this. I've been visiting Infineon in Munich 20 years ago. They do chip design, not with the other system, and they had their chips pinned on the wall. It's something like 4 by 2 meters plans printed on plotters. Really cool. You could do this with Eagle as well, but okay. No, it doesn't make sense. So we want to add something, drawing frames and components. So now you have to learn some commands. The first one is the add command. Add something into my drawing. And if you go into the area here, you can look for it. Yeah, there it is. You get a pop-up that says add part. It's also written here. And yeah, if I click here, click, first time it loads all the libraries now. That's basically what we have seen in the control panel before. You see? Oh yes, I have double the. Okay. So you see it not in double but in one. So let me just do something. That's something I do with the command line. That's much quicker, but of course you have to know the commands. What I do now is to unload all libraries, and now I load the one I wanted to say. Well, it should be use X. Here we are, and now I do an add. You see, I can type it as well. I'm more the type guy because that's something I've learned it from the beginning. So now you see the list as you see it. There are a few more. These ones are my own libraries. I have a totally different setting as you have, because you've seen I have about 20 different Eagle versions installed. I'm permanently changing something, so don't worry if it does not look exactly as it does in your systems. But okay, there I have the libraries. As a perfect Eagle user, you know frames, drawing frames are in the library, which is named frames. If you don't know it, you can scroll down and read all the stuff, or of course you can search for it. And the search function I will show you in the next component. And this, I simply click here, I hit the F key, so I jump to F, and then now, as I said, there's a frames library. Here it is, and I open it. And there are a number of drawing frames inside in the TINT formats or also some US-based formats. I'd recommend to use one of these, A4L, landscape dash lock. That means there's a locator. There is this frame has been drawn with the frame command, where you added rows and columns. So you see, in a moment, I click on it, I can say OK, or I can do a double click onto this one. Then you see it's following the mouse cursor, and I place it. There is an origin, the coordinates origin. It makes sense to place it on the coordinate origin. Simply, if you decide to move it later on, it's more obvious to click there on the left bottom corner than anywhere else, so you get it better. It's not critical, but it's a matter of proper working. There are a lot of things you could do. So, okay, it fits. But I also recommend work in a style so that you, proper working. Place this frame on the origin. name components in a way that it makes sense. Also name nets if it's necessary. It's much better and better readable also in the layout if somebody has to look into the board. Of course, it has nothing to do with functionality, but it's better to have a signal that's named ground or plus 5 volt and not N$12 or something like this. That doesn't help if you search something. Of course, the board is the same. It works the same as it would be named whatever you want to, but it makes sense to do a proper work here. Okay, click, left click. If I move the mouse away, the next component is on the mouse. I don't need a frame, but it could happen if you have a resistor, you don't want to place one, but you want typically have 2, 3, 4, then you can simply click, click, click. And I don't have to abort the command or terminate the command. I simply go on and now click into onto the icon again. Then I come back into my dialog and I can place the next one. So save mouse clicks. That's save, take care of the environment, save mouse clicks. Okay. So the next step is I want to have a timer. That's I know I'm in electronics, an LM555. That's my classical example. I always take it. I don't know why. And you think the name is LM555. And now if I scroll here up and down, I don't know where to look. Okay, I don't tell you. I don't find it. So I use the search function. And I click here into the search line. And now I type LM555, and I'm sure it's inside. But now I hit the enter key, and you get the message, sorry, no match. The question is why. Eagle searches exactly this word, LM555. And I know that such a timer is produced in different variants. There can be through-all packages, it could be a SMD, a surface mount device, and this is part of the name. So if I'm not sure how it's named, then I unsharpen my search. I use asterisk for any components. What I know is 555 must be in this name. So if I go there and add an asterisk here and one in front of the text, and now I hit the enter key, I get matches, quite a number. You see also, okay, AMP connectors, I don't want to use them because they also have 555. But if I go down or close this one, you see, for example, I have the linear library. And I open this one, I see this is the name. If I would have searched for LM555D, he would have found it, but he didn't. So now you ask, why don't you unsharpen the search by default? Good question. I can't tell you why. Fact is that this search function will be improved. There had been some attempts in the early version 8s, but there were some difficulties. I think the reason is in the way how this search function is implemented, or has been implemented in the beginning, 20 years ago, or 15 years ago maybe. And so there were some obstacles. They say, okay, let's postpone this, but we will have a better functionality soon there also. But now, at the moment, you have to unsharpen the search, and then you find components. And now you decide to use one. You see, all these packages have 3D models already linked. So it makes sense to choose one of them if you decide to go to mechanics later. I take one of these SO, surface mount devices. And you have to decide about the package now in the schematic. There are other systems that do it the other way around. They say, okay, don't care, take the symbol, and we take care on the footprint later. In Eagle it's a bit different. The reason behind this is we wanted to have a system where you design the schematic, and I take the schematic and give it to you. You have no libraries in the background. You're on vacation on the Bahamas, but you have to do the schematic and make a board of it. I simply send the schematic to him, he has it, and then he can create the board, because all the information is in the schematic. And then you get the components in the board, so you don't have to take care of libraries or do some linking afterwards or whatever. And there's also one thing, as soon as you start with the board, we have a so-called back and forward annotation. So each change in schematic will be transferred automatically in the board and the other way around. So yeah, that's so basically the reasons. You have to take care, but it's not a problem if you decide I don't want to have a surface mount device later on. You can simply change the package. You see, it's in the library. There are two variants. I can decide later on in the layout design and say, oh no, I don't want to have the big one. I want the smaller one, whatever. I simply change the package, because all the library information is in the schematic and in the board, and so I can simply change when I want to. So it's not so critical. I decide this one because probably this one will be the package I want to use. I say, okay, now I have it here on the mouse. For all I've never tried to do this, it's very, very handy to have a mouse on the Mac and on all systems, because with the wheel I can zoom in and zoom out. If I press the wheel, I can pan around, drag the drawing area, and of course right mouse click rotates my symbol by 90 degrees in the schematic. Left mouse click, okay, place it anywhere, place it here, click, here it is. You see, you get automatically a lane, IC1, and you get a so-called value, the LM555D, so you know what's the component. And so you go on adding components. As I said, don't terminate the command, you don't have to. I can also either click on the icon again. In this case, I could also hit the escape key, I come back into my add dialog, and then I go on searching for components. I clear the search bar here, I get the whole list, and now I add some resistors. If you look into the library, we have the European representation of the symbols, we have the US representation. It's a crazy world we're living in. There I must say the US people living on an island, that's true. They have no idea of metrics, or it's a bit crazy. No, it's not true. Meanwhile, you know what a millimeter is. They have already heard it. And it's quite interesting. I have a customer, he's working for some companies, and he's working for NASA and for I think what's for Boeing, something like this I'm missing the English word, okay, doesn't matter. And he has to work in inches and in millimeters, because in NASA, for example, they are working in millimeters since a long time, and that's the reason why they missed something when they wanted to fly on the moon the second time, because they mixed up inches and millimeters or something like that. Okay, no, that's probably not true. But most people already know about millimeters, but it's really crazy. And the nice thing is, of course, maybe the Europeans or the rest of the world like to draw bars, or maybe boxes, and the US people like to draw something like this. That's a resistor, a US symbol, and the C's look like that. They don't want to have bars, they have something. So, okay, different. So we have both variants of these symbols here, and you choose what you want to. I take a resistor, this one, and here again, You see, there's a number of different footprints. Meanwhile, packages are footprints. You consider.
Can I just
Yes.
raise a question about this?
Mhm.
I always struggle with this.
Yes, I can imagine.
Is
Yes.
when I'm browsing for the package I require, and resistor is a good example. I've got this dimension here,
Yes.
but it's really difficult to relate that
To this.
to that.
Yes.
Is there anything that can be done about that?
Not yet.
Okay, fine. I mean, that one isn't too bad, but some of them it's really.
easy. There is it. Grid 5 millimeters.
Yeah.
No, yes, it's always difficult, of course, to find the fitting package, the correct sizes. That's this enumeration or whatever. It's a bit crazy because you have to know what it means. If you, for example, this.
I mean, if there was a grid on there, I could just count the dots and it would be fairly easy. Oh, that isn't a great example because that is reasonably clear, but quite often it's really unclear.
Yeah, if
a grid was up there,
if you look
it
into
would be
this,
much easier.
there you go.
Yeah, exactly. Yes.
What is it?
Who
Yes.
knows?
No
Yeah.
idea.
No,
That's
I'm
true.
glad there's not this many.
That's true. Okay, that's something you have to say. Okay, yeah, it looks it's a MELF 0102
Yeah.
W for Y, I think. So it means it's bigger than the others. And we can check because this one will be an R. Yeah, you see, difference,
Yeah, yeah.
wider. Yeah, and so you have to know the
Yeah.
Yeah, I think with the through hole ones, there's no indication of like whether it's a half watt resistor, a third watt resistor, a quarter.
yeah, that's correct. But yeah, that's this naming here is nothing we invented. That's coming from anywhere. I don't know. What I have here the 0204 /5. What does this mean? It's the resistor. The body of the resistor has a diameter of about 2 millimeters and a length of about 4 millimeters. And the grid is about 5 millimeters. To be honest, it's not 5 millimeters, it's in inches, it's 5.08 millimeters.
Yeah.
And so that's an approach to describe what this should be. So that's really crazy. And there's nothing written, it's a quarter of a meter or whatever. That's true. And if you go down here, even here, if you go to the surface mount devices, just thinking about 0603, it's also, it has to do, it's related to the size of the package buttons.
Yeah, it is. But that's the imperial size, I think. 603.
Yeah, okay. So yeah, of course but yeah, that's something you have to know. And, but if you look into an electronics distributor catalog, of course, you find these expressions usually, and then you might be you might be not surprised if you get them and they will fit. Okay. Yes, that's really crazy, and we had times, especially with the SMD components. There's something, it's, for example, QFP 100. That's probably looking like this one. It's a square one, 100 connections, and it has exactly the same naming, or the package has exactly the same name. If it comes from Motorola, it's okay. If it comes from Siemens, there's a different grid or different pitch. So that's very difficult. Okay, meanwhile, that's the reason why we have this IPC stuff, where we want to have a standardization of the packages. So that's very, if you have a designer, you have to be very careful to select the components. And that's the reason why I said a lot of people design their own libraries, and they order exactly these components from this manufacturer with this manufacturer number, whatever, and only this one, nothing else, because then they can be sure it will work. So okay, yeah, that's a different problem. Okay, so you choose a package let's take a 1210 or 1206, something like this. I say, okay, I have it here on the mouse, and I can place it again. By the way, what I did not mention yet, I place 2, 3 of them. So I have them there. You see, it's automatically named R123, and so you start creating the schematic. Of course, what I'm doing here is nonsense, because it's not nonsense, but this schematic will never work. We will never get it running this way, because I don't have a plan watch, but this should be in the end, but it's only to show you. So I have components placed, and the next step is, of course, I have to do some connections. I want to connect this pin with that pin, and therefore we need a second command. It's the net command. This one. If I click on it, I have, don't stop the command, I simply click the next command. And then if I approach one of these pins, this electrical connections here, connection points, you see a green dot. This green dot indicates where you have to start the net. By the way, meanwhile, it's the only point where we can start the net. In early versions this was not so obvious, and you had to take care on the grid setting. You see we have 0.1 inches as a default grid here. All the symbols we have there, all the pins we have there, are all placed in this 100 mil or 0.1 inch grid. Some minutes before I joked about the inches. Here we have them. That's the reason. The reason is that when we started with Eagle version 1, all the components have been produced in the inch-based grids. Everyone will do it. And no, that's not correct. Siemens were the first who started to make components in millimeters. But Eagle also calculated in mils in the beginning, and so that's the reason why we have this 2.54 millimeter. If you prefer to see millimeters here, there is a grid icon, this one. And then I can switch to millimeters if I want to. It's 2.54. If we would have met a year before, and I said never change this grid, because if you change it, for example, to 2.5, you would never get a connection from net and pin. Meanwhile, that's not a problem, because even if I change the grid, the net jumps onto this connection point of the pin. No problem at all. But here again, do a proper artwork. Do work properly and use this grid. It's very ugly if you zoom in, you see the net jumping this way and then going straight along. So makes sense to work in this grid. Okay. Okay. If I say switch to millimeter, I also can display the grid if I want to. So okay, then I see this in the background. Sometimes it helps. And then I have the net command is still active. I go here. You see the green dot here. Click on it. Here I have the net. Now the right mouse button changes the style, how it is connected, 45 degrees. Depending on how I start with the mouse, go down first, and then I have this one, go this way, so no, that way. So depending on how you move out of the pin, you get 45 degrees, or you get what is it, 125 degrees. So that's something that's decided by your mouse movement. I click again, and then you have a direct connection. Basically, I use 90 degree, 45 degree, or direct connection. Okay, and if I go there and click again, the net drops from the mouse cursor and the connection is done. Okay, this net gets a name automatically N$1. So if you have so small nets without any real function, then that's not a problem. If you would like to give the net a name, then you can do this and name it, but let's next step, one after the other. Okay, so I do connections from here to there. Or if I go from here and I want to connect this one with that one, I I click on this one, and you see, we call it junction. That's the connection point where I see, okay, these two nets are connected. If I would draw something like this, go here, this is connected, this one of course is not connected, that's here. That's all functionality of the net code.
Can you set jumpers on the net so it automatically puts a...
No, I can't set,
Okay.
you could draw them,
Yeah.
but of course, no, it doesn't do it automatically. You could do something like this, go out, no, this way, here, then I go there. Then I could do something like this. Okay, no. Okay, yeah, that's what I didn't want to do. Yes, you could bend them, but it's not the way we draw the schematics here. And back. Okay, yeah, that's the way how to connect stuff. You see here, we have the resistors. We don't have a value for the resistor, so we have a name, but I don't know, is it a 1 kilo ohm or is it a 2 kilo ohm or is it whatever. So that's one of the important things. So now I could, for example, do a right click onto this resistor. You see a number of commands, and there is one which is called value. Take this one, and it asks me for a value. And I write, I don't know, 1K for 1 kilo. We don't have an ohm sign, that's not the part, so you have to use 1K. And the next step is, you see this too close together. Now I have two texts overlaid. I can do the following. I can do a reposition attributes, for example. Now they are, you see an origin point for the text. Okay, let me move it out a bit. No.
Let's replace the smash command.
Yeah, that's to replace the smash command. Yeah, that's correct. Now the texts are not anymore fixed connected to the component, but I can move it. I can place it anywhere else. Now it jumps in my 2.54 millimeter grid. You have seen in the, let's go into the grid icon, style, you see we have an alternative grid set here. I can switch it to millimeters, doesn't matter, it's a tenth of the usual grid. You can set it whatever you want to. But I can use this alternative grid. I have this text jumping. Now I use one of my fingers and press the Alt key, and now this jumps in the alternative grid, and I can place it wherever I want to. So it's a bit for fine adjustment, for example. I simply put it there. It doesn't make sense, but just to show you. Moving something, you have the move command, click on it. You see, you can move it. I can also move a group. Use the group command, click on it. I can simply drag a rectangle around all the objects. You see, it's highlighted now. And now I can simply click onto one of these elements and move it, and click and drag it away. So I don't have to select the move command. It's also if no command is selected. If I click here on to stop and I go into the drawing area, you see the group command is always active now. So I simply draw the group, click on one of the objects and can move it around. So I don't have to select commands. So that's the, if nothing is selected, the group is active. And if I have a group, then I can move something around. Okay.
When you're moving, is there any way, because you have to click directly on the origin for the component to move it, do you? Is there any way to make a big hotspot on it so you can just drag from anywhere?
You have to be near an object.
Right.
Because if I'm not in an object, as I have done here, then it starts to draw a group.
Yeah.
So that's correct. I have drawn a group, and then I click here. It hasn't to be an original component.
But if you didn't group it, you have to get it.
Okay, if I didn't group it, yes. Then I click onto one of the objects and then I can also move a single component. Correct. Yes. Or even this one.
Is there a way to change text to font size?
Text the font size.
for the
Yes.
actual objects themselves.
Yes, so that's something I would do basically in the Eagle script file. If you would like to have different texts, do you change the text size?
I do it on the board layouts because
Okay.
I find that the components from different libraries, the
Yeah.
text can
Yeah.
be generated
Yeah.
different sizes. So I have a
Okay, I would say that it's not necessary to change the sizes in the schematics. If you want to do, you can, of
a lot of
course.
my components are very close together. So it gets a bit of a muddle.
Okay, yeah. Okay, if you want to do it, of course you can also do it this way. If I would unsmash all the texts here, this could be done, for example. I do a group selected. I looking for the smash command. It must be typically this one. It's reposition attribute, new name. Click on it, and now how to access the group? If I click with the left mouse button, I access or I execute this command on the component I click on. If I were to do this with a group, there are two options. I use control, now it's command, control in your systems, in not Mac systems, and do a right click. And you see all the text have got origin, and so they are editable or changeable. And you could also do simply a right click, and then you get a context menu. There is reposition group. Okay, we have already done this, but that's also possible. And now I could go and I have again. It doesn't matter. I have the group, or I don't know. Yeah, it was still existing, so I have the group, and now I could change the size of the text in general. Therefore, you have to know there's a change command. Change is the range here. And there I have a lot of options. I say size. Yeah, that's the default size. 1.778 millimeters, it's 70 mils or something like this. So that's also, let's make it bigger. 2.5 click. And then command right click. And it's changed. I have changed the text. I can't change the texts inside the symbols. They are fixed. There's no way to do this.
My main problem is naming the nets. But if you've got a chip with a lot of outputs, one on top of each other coming out.
Okay, if you want to name the nets, of course we have the
So I'm getting ahead of it.
you could use the name command, for example, here. And yeah, you type the name. That was it. I clicked on what? I think it was Q. So let's name it Q. And you can also decide to place the label or not. Makes sense to place the label, so click on it. Here I have, it was the correct. Yeah. You see now I have the big names already because I have preset this and it's valid for all the text I'm placing next time. And then I use also the alt and then I say okay, Q. So I can go on. The name command is selective. Click here, name it this, and so on. And we will have some improvements there as well, so that we also can name, if we have a bus, A0 to A15, let us say name from here to there, and it will be automatically generated. Will be in next version, next week. Besides that, the texts for my opinion are too big, so it makes sense to really name the schematic nets, because if somebody has to read this, it's better understandable. Think of some service people who have to go to the customer and they say, hey, my schematic does something wrong, what can I do? And it makes sense to have the names of it. It's much easier for them to understand what happened. Okay, so that's basically a very simple schematic. There are a lot of more of these commands. So, do you have questions? Something you want to know or you would like to ask at the moment? No. Okay. So, yes, name command. Of course, we have name and we have value. My command, split command. This I would leave this as it is because it's not. It's of course important, you can use it, but I think it's not really necessary to do it in the introduction. Copy command. Of course, I can go here and say, oh, I need this again to copy it, so I can copy it and have a second one. You see, it's automatically enumerated, IC2, and it's going on. Of course, I can delete something. I can replace something. If the guy tells you, the guy who's doing the layout maybe, he says, hey, you selected here, I don't see it, but I see it's an LM555D. That means it's the surface mount device. I could already here change the package again. I change my mind and say, where's the package now? I lost it. No replace. What did to do? Wait, no. It was replaced. No. Okay.
Under the spanner.
Forget it. No. Yeah, we could do a replace, but that's what I wanted to show you. Attribute. I can have attributes. That's something I would like to show you with the libraries. Replace command. I can exchange components. I can say, okay, I don't want to have this resistor. It should be something else. Then I could use replace. Again, swap, pin swap. That's something I would like to explain later when we do a library that makes sense and you understand what all this can, what all this mean. We have the line command if you want to draw something. Okay, good idea. Line command. You see, I have the symbols are drawn in red, the nets are drawn in green, and this is always a layer behind this. So we have different layers where we draw in. So the net layer is active at the moment. I click here, you see the number of layers we have. Important is 91, yeah, that's for nets. Then we have the 94, that's the symbols layer. That's you see here the red boxes, that's drawn in the symbol layer. We have a pins layer. If I display this one, I get some information written to the pins. I'll show you in a minute. I have names and values. These two layers, the texts, the name texts are in the names layer, the value text and the values layer. Why I'm doing this is I can display them or not. I say, don't show the values, switch off the layer. How can this be done? I go here to this icon, it's the display or layer settings icon. Click on this. Here you see the layers that are displayed. If I click on the pins, you see I get a lot of information. That's quite important for the designer to know what is it. You see, for example, here the input pin. This means signal goes into this component, there with output pin. That means, yeah, signal comes out of this. We have power, for example, V plus and G and D. Yeah, power voltages, they have a special meaning in the schematic because we also have an electrical rule check that checks the logic of the schematic in a very simple way. If I have a power signal, this means there must be a source anywhere. Anywhere I must get ground from. Or if there is no connection, Eagle will complain and say, hey, what is ground? No supply for this. There must be, you must have any source for this. The same with V+. Or if you have some directions in input, and if I connect all these three input pins, it's not very likely that this is correct, because only input pins together doesn't make sense. Only output pins together doesn't make sense. So there are some logical checks in Eagle that might help you in drawing a correct schematic. There are some pins that are called passive, so they have no real function. That's typically for resistor or for capacitor. I think it's also the case, it's still the case, that if you have a resistor which is connected with one pin, Eagle won't complain. Because in this case, yes, he will complain. But if you have 3 pins, think of a transistor with 3 pins, and one is not connected, and you would have set this pin directions to passive, which is not correct, then you would complain and say, hey, no. I didn't think about it. And that's not true. If it would be passive, then it wouldn't. No. Okay. There's some simple logic behind where we try to point you to some situations in the schematic and say, hey, is this correct or not? Yeah, 3-pin components or more pin components, if there are pins left open and they are not input, output, power or whatever it is, if it's passive or I/O, that's what we have, and it does not complain. If we have a direction, it would complain because I expect an input pin that should be connected. So there's some logic behind. We will do this a little bit. Get back to the layers. So you get a bit more information about the pins. Usually it's switched off because I not really need to see it, but if I want to, I could switch it on. So the same, I can say I don't want to see the values. If I switch it off, I don't see the values. Or I can even hide the names if I want to. If this makes sense, I don't know. Sometimes it could make sense if people don't want to show you all what you have done in your design. Info and guide is not really used in electronic schematics, and we have buses. That's actually, I tell you a bit later. There's something about modules. You can have hierarchical schematics. That's a step more. That's what we are drawing here as a plain schematic on the same level. I could decide to have a filter, for example, some components arranged, and I define this as a module. Then I would get something like this. Let me save the schematic. By the way, it doesn't hurt to save the stuff. And again, use a name you understand what you have done. 1, 2, 3. Just let me show you a hierarchical schematic. I have to go into the examples, and then I have oh, it's not on the inside. Electron, this one. Okay. No, that's the wrong one. We don't have a hierarchy. Okay, so I have to take one of these. Just a moment. There must be yes. You see, I have a lot of projects. That's mainly support stuff. And I've never deleted it. I should do this. Yeah. But most of these files I have there have some errors. And sometimes it's quite nice, but here. This is a hierarchy schematic. Okay, so the schematics speak in German, but it doesn't matter. So I have, for example, kind of power supply, part of the power supply. This is a module. It's called NetStyle. It's here. It's a power supply. It consists of 2 pages. And this is the main schematic where I have some modules. And if you look for, no, that's here it is. I used this model once in the schematic. So this box contains these 2 schematic pages. And I could use, there's for example a parallel port. Where is it? This one, that's the module. It's a component, it's very simple, just an example. And if you go into the main schematic, you see I have used this module 3 times. I have 3 parallel ports there. So I have a hierarchy in the schematic. I see some boxes, And each of these boxes represents some electronics inside, but it's an easier overview. But finally, the schematics get more and more complicated. Because if you go into the layout, it's getting, it's not so easy to find out which component belongs to what. You have a combination of module name plus component name. I think it's something we should not go into details, because this is subject to be changed in the next time. The idea our developers had in the beginning are quite good, but there are some things customers would not expect to work in the way we have done it some years ago. So Autodesk sees this has to be changed, the dev team. We have a lot of people working for more than 20 years in electronic design software development. So they come from companies which are all our competitors, and they have some ideas and they have the knowledge how this should work, how you would expect to work with hierarchical designs. So we will have some changes there. So I just want to show it. There's also, I will mention this in my script afterwards, a chapter in the EV manual that will describe how this works. If somebody really wants to go into detail, go into the manual. There's really step by step how to develop such a hierarchical schematic. So you see that's quite a lot of stuff. It's 11:59. 15 minutes. You have to listen for the 15 minutes. Okay, just short into hierarchical schematics. I really should do a lot of stuff here. Okay, back again into our good projects here. It was the 1, 2, 3. Okay, open it again. Here we are. So, I mentioned the electric rule check. Let's try what happens. So, I click ERC, that's the command here. Click on it. Okay, here it is. Click it up. Yes, and you see a lot of messages. The first consistency not checked. That's clear. I have no board. If I would have a board, Eagle would compare schematic against board. Are there any differences? Then it would be mentioned here. Okay, we have errors. We have errors and warnings. That's something. An error can be a warning, and you can say that's okay, but a warning can also be an error. And in my opinion, if you go into the electric rule check, please read all the messages. Doesn't matter if it's an error or warning, because in both cases it can be wrong, and you have to react on this and do something in the schematic. If you click onto one of these messages, unconnected input pin, let's start with this one. It shows you a variable to look at. I can move this, can zoom in, say, okay, it says unconnected input pin. If you go to display and switch on again this one, you see, okay, it's true, it's an input pin. This one is checked. And you see again, I get the window. Now I have to react on this. If you say, yeah, that's okay, then you could approve this message and say, yeah, that's what I want. It should open. I don't want to have it connected. If it's wrong, then do something. Connect it. So in this case, I would do this. I connect it. Doesn't make sense to. Okay, I have to change the style. Of course, you can also draw something like this, but I wouldn't recommend this because nobody understands. Okay, now go back. Okay, so I have to choose with the right mouse button the correct style. I go down here connected to this resistor. Okay, you see, I'm an expert in drawing schematics. You would do this better, and all your customers also would do this better than I do. And even your students can do this better. No? Yes? Okay. Okay, I should join you. Is it how expensive it to study in your university?
Yeah,
Is it?
good discount.
Okay, good. Can I start this semester?
Yes, we've got space.
Okay, no. Yeah. So I do a connection. If I run the ERC again, you will see, I assume, yes, we had 11 errors before, now we have 10. So you have to work through the errors and try to get this fixed. We will fix it. If you don't want to fix it and say that's correct, because my pin number 2 on this resistor doesn't need a connection, because that's where I would like to put my finger on, then I say that's okay, and I approve this, and this message goes into this approved branch. I can look into it. If it is like, oh, this was wrong, I can disapprove it, and it comes back into the warnings message, so I can play around with the messages here. Okay, that has no value. It doesn't mean it's worthless. It says there's no value behind. So yes, you have to fix this. And the more important things is, yeah, this is about power, and that's the last thing we do before we go into a break. If I click here, then it tells me there is no supply for power pin. IC1, GND, great, no supply. This means, yeah, I have no supply. It must come from anywhere. And in this situation here, I could, of course, if I have maybe some power supply in my schematic, of course, I have to connect this anywhere. And what Eagle wants to see is a supply symbol. That's a special symbol coming from libraries to represent a power voltage or a supply in the schematic. If you, it's a bit complicated. Let's keep it easy, because what I could do is I could show you the board. I could say, okay, these ground pins are already connected, but and so no. But let's keep it simple. Eagle wants to have for each pin, no, for each voltage, which has a power pin. In our case, it's GND and it's V+. He wants to see the power symbol. Why? So that Eagle knows that you know that this signal or this power voltage is in the schematic. You have seen it. You place the supply symbol. This says Eagle, tells Eagle, okay, you know there is this, and you have possessed it in a way, so you don't overlook it, because you have no supply, nothing works. And therefore we do a simple thing. The first thing is I go into the add command again, because I'm searching for a supply. And there are two libraries, it's very simple. It's supply 1 or supply 2, here and there. So they differ in the, it looks like, that's the ground. I take this one, I double click it, here it is. And I place it, I could directly place it on the pin. It's not so nice. I put it here. Okay, it's not connected yet, and now I take the net and go from here to there and connect it. And I could also do the same here. So I can add it. By the way, if you go to the add, I did a left click to go into the dialog. I could also do a right click on this one, so that are the fine things, the details, and choose from a list of the recently added parts. Got you. And also do a connection from ground to there. Please check the name of the net. If I come from the supply pin to the power pin, I think it should be automatically named ground. If you do the other way around, or if it comes from anywhere else, it makes sense also to name it ground. If you wouldn't do, you also would complain and say, how pin GND is connected to N-order 25 or something like this, then I would go into the schematic and name it so that it fits together and it is no longer complaining. Let's simply start the ERC and then we will see. Yes, you see, these two messages for ground are done, no longer there. Then I have to do the same, of course, for the V+. There I also don't have a supply, so I have to take care of this. The ideal status, whatever it is, to have no errors or warnings, and then I go into the board. In a number of cases that's not possible, because if I take components from the libraries, here I have V+ as power pin, for example. Then I take, I don't know, another component from another manufacturer, and the pin is not named V+, but +5 volts, for example. But I have to connect these two voltages, because this belongs together. Then I get a message, and he says, hey, V+ is connected with this and that, and then you have to decide, is this correct or not? And then I say, okay, if it's correct, okay, I can approve it, and then it goes in the approve branch, and then you have no real errors, but sometimes it happens that you will have some errors or warnings remaining in this ERC. On the other hand, if you have no warnings and no errors, this does not say that your schematic is working. So it's just a simple logical check we have for the schematic. Okay, so so far I want to mention one more thing. I know it's a lot of stuff, but yeah, you're here. You nobody forced you to come, so that's your own decision. No, okay. I just want to save this again and go into another schematic. I can also go this way. File open. Go to yes. Oh yes. It's 9 or doesn't matter. I use one of the examples here. Projects. Example. I just want to use Hexagon. It's an old one. Open. Here we are. So somebody. Okay. It's very old, but doesn't matter. What I want to show you is here you see we have some LEDs, of course, and we have these blue lines. These are so-called buses, and the bus is a graphical representation of a number of nets inside the bus. You see the bus has a label here. It's named D0.7. This means there are nets inside D0, D1, D2, D3. Why do we use such things? Okay, it's better readable, better understandable.
Just clearer.
It's clearer
schematic to read.
So you see where the bus goes to. Okay, you see because we have components like this one, it's always the same. And there we have D0 is to D7, and they all are connected in this bus. They are connected together. If I would have drawn all the nets, it's unreadable. If I tell you now, you even had to draw nets and connect them, this also would work. Okay, that's something I can mention. Okay, but it's, yeah, just I want to show there's the bus command. That's what I want to show you in a very short. I can draw it this way. If I finish the bus, I hit the double click, then I can already decide, okay, there are predefined buses, that's something, yeah, that we wanted to show, yeah, canvas, I just see it, so something like this SPI. I can give the bus an alias, whatever it is, blah, blah, blah. No, reasonable names, please, as you have seen, maybe SPI or whatever. And then I can say what is inside the bus, which nets are inside. You get all the nets here in the schematic, in the list. You can choose from them, or you can even choose new nets that are not already in the schematic. You want to draw them later on, and then I can decide what's inside the bus. And if I say, I simply take some of them, also I have to select, I think I can select more, no, yeah, and then go there. Okay, that's what in my bus, and then I say, okay. Then here I get I have defined an alias for this, so it's the blah alias, and if I do a right click onto the bus now, I can also do a breakout bus, and I can say, okay, now bring all nets out of the bus and place them already, or select some, or do one of the nets. Let me, okay, yeah, okay. Again, right, breakout was, I say all nets, for example, and you see what happens. I get all the nets already from the bus outside and can place them, then I connect to the devices I have inside. So, yeah, doesn't make sense, but just to show you that how I can define such a bus structure, bus line. You don't have to queue here. It's not a real bus stop. No, just kidding. Sorry. Yeah. Okay. Yes, buses. Then let's go back to our previous schematic. No, don't save this nonsense. I know. Okay. 1 minute. Next step: create the board. You can do this at any time, even if you have only one component placed, doesn't matter. If you would like to start already in the layout editor, you can do. And I simply go there and click onto this icon. That's the board command, so to say. I click on it. It tells me there is no board. Do you want to create it? Yes, of course I want. And then I get this one. That's the layout editor window. In my version, that's a Eurocard size 160 by millimeters. In the smaller, in the freeware, it's 180 millimeters. Just as for orientation of the size, you can change this. But what you see is that you get the components we have selected, we have placed in the schematic, and you see the signal, the yellow lines. That's the connection, the nets we have drawn in the schematic. And that's randomly arranged, and then you have to start to do the layout. And the last step, okay, I will need one further minute. I mentioned that we have a back and forward annotation. So if I have both windows open, and as soon as you have both schematic and board, you have to have both windows open. If you would close one, you get an error message, but it doesn't matter now. If I want to change something, I say, oh yes, this R1 doesn't make sense, I want to delete it, and I do this. I do right click and say delete. Watch the layout, it's vanished. If I go there and say, oh, I have not defined the value, it's this one, it's here and there. So all the actions are transferred. There are some actions I can't transfer from the board into the schematic. Then it says do it in the schematic because that's not possible. But we have back and forward annotation. So at all time I have the same situation, the same status in board and schematic. You see the screen, whatever this should be, a kind of flash or marker on the map. If this is green, then it tells me consistency is there. If I save here, you see the exclamation mark says unsaved board and schematic. I save this one is saved, that one is saved automatically. If I would close this one, I get this window. I get this warning where I say for that animation has severe. This means please, before you go on now, think is this correct what I have done? I know people sometimes you click the X button to close the window, then you have the schematic and you go and work it. In earlier versions we didn't have this board here, and people go on, work, and then you load the schematic, for example, on the board again, and then you can say, hey, there's an inconsistency. All this stuff you have done the last day, I have not on the board. Do something. Make it consistent again. If I have differences, then I have to decide what to do. There's one thing, undo the stuff I have done already, until it's consistent, to do this again. Or maybe go into the board, for example, and add on the stuff I have already added in the schematic, so it's something you have to take care of. But if this warning is there, then fingers away from keyboard and think, or
You try it.
think, yeah, what do I have?
I know in some-
Sometimes, in some cases, it makes sense to close a file and do something maybe there or that. Sometimes, but usually not.
I was going to say, in some packages you get the option to forward the design changes from the schematic into the
Yes.
board to correct them.
That's correct. Some software allows, has the option to say push it now from the schematic into the board, for example.
Yeah.
But on the other hand, sometimes in some packages you have to do this. And if you don't do, then sometimes it's also not so easy. And we have some problems with, not problems, but you have to take care, especially on libraries. If you go to Altium, for example, I think there's the case you can push into the layout. But if you don't have libraries in the background, I don't know exactly. We very often see if somebody comes with files and says, hey, I have an Altium project, and I would like to transfer it into Eagle. We can do this, but in most cases, we don't get consistency, because the packages are totally differently named as you have it in the schematic, and you don't find a match. I think that's the reason is because this Accent ASCII format, I think, is what we use. There's no information about this. And you need libraries in the background. If you don't have the libraries, the correct ones, the correct versions, then you won't get it consistent. So it's maybe a bit more challenging to take care of this, but it's very, very convenient to work with background implementation.
Is there a mechanism? So, for example, if you add another resistor here now,
Yeah.
and then save that, and then open up the board file, it will say not consistent. How can I then add that resistor?
There's no convenient way. You have to place it manually, name it identically, choose the value, do the connections. So you have to do this manually.
Yeah.
Sometimes, that's something our developers, this was one of the first steps. One of the guys came to Kleiskirchen in Munich, in the former Catsoft headquarter. I said, he had exactly the same question. And then I said the same. I said, hey, Eagle knows everything. Why you simply push it into the board? That's something, maybe this will happen.
Assuming you got into this unfortunate state, is there a way to find out what the differences are? Can you generate a report?
Yes. Okay, let's do the following. Let me. I have the board closed.
Yeah.
I say delete. I do a name command, just name it 1, 2, 3. Okay. Now I load the board again.
Yeah.
I click here again because I want to load the board. It says no backfold annotation. It also says run the ERC. You can also start the electric root check from here.
Yeah.
Okay. And now you get this message part not found.
Okay.
That's the first step. It's not the whole story, because we only check the part in the first step.
Yeah.
Then you add the part into this board, and you run ERC again, and it will tell you, okay, the value is wrong, or you have different connections, or the signal.
So you just have to go up to the
Yes.
the consistency errors, try to
Yeah.
manually correct
Yes.
them, and then
Yes.
eventually, if you really
Run
have to,
ERC again and again until
Yeah.
it says it's consistent, then you can go.
So, but it should be possible to get it back in sync.
Yeah,
Yeah.
it's not, you get it back in
Yeah,
yes.
yeah, sure. Okay.
Yeah, there's some situations, if you connect, for example, in the layout editor, if you connect GMD and plus point once, then it could get complicated to fill this out. Where to cut the nets so that it fits again to the schematic. This can be challenging. There can happen that you say, okay, I have to delete the whole signal and do it. This might happen.
But it's recoverable with a bit of manual
Yes.
intervention. Yeah. Okay.
Okay.